Hello. In this video, we want to graph y equals x cubed plus 2x squared minus 7x plus 4. Here's the thing. We're not told pretty much anything about this. We want to find, though, the end behavior, all the zeros, find the y-intercept, and then graph. And here's the thing about this. To graph this, we could try and factor this using grouping, but grouping's not going to work. So that's a problem. What we can do instead is we can actually kind of cheat a little bit. So what we're going to do is we're going to use the calculator to find a zero. You ask, how in the world am I going to do that? Well, that's where the calculator comes in for this video. I'll see you there. Alrighty, welcome back to the calculator. Let's go into y equals, clear anything that happens to be there. Okay, on y1, let's type in the function x cubed, so just x caret 3, right arrow, plus 2x squared, minus 7x plus 4. Awesome. And to find zeros, we just need to find where the function either crosses or touches the x-axis. So if you press graph, you're going to get a graph of this function. Now, notice that you might not be able to see everything here. That's fine. Or you might have a different window than this. If so, just press zoom 6, and zoom 6 will take you to the standard window of -10 to 10 for the x's and -10 to 10 for the y's. Now, what we mean by zeros is where the function crosses the x-axis. And if you look at the x-axis, -1, -2, -3, -4, -4 is a zero. Also going right 1, that's a zero as well. But we can also see this from the table itself. So if you press second graph, which should be this, then you're going to start seeing a bunch of values here. Now, if you don't have integers here, go press second window, which is second table set there. And on the table start, say something like -4 or something like that. That's fine. But your delta table is very important as well. It needs to be by 1. Independent, auto, dependent, auto as well. Awesome. So your table start, make sure it's an integer, and then make your delta table an integer as well. So if you go back to the table, you will see this right here. Now, notice that our zeros occur wherever our y value is 0. So notice that there's a 0 here and a 0 here. So there's a 0 at -4 and there's a 0 at 1. But even more important, we do need to be able to see the graph, because if you notice, it crosses at -4, but at this 1 it bounces. So this 1 has a multiplicity of 2, while the -4 has a multiplicity of 1. This is important information, and we're going to use this information back at the notes. I'll see you there. Okay, welcome back to the notes. Here's what we're going to do. We're going to use synthetic division to prove that those zeros are in fact zeros. So the first zero that we saw was -4. Use an upside down division, use 1, 2, -7, and 4. Bring down the 1, multiply, add, multiply, add, multiply, and add. Fantastic. Notice that I just proved that -4 is a zero of this polynomial function. But let's continue. We're also going to prove that 1 is a zero. Now notice that I'm just using these numbers here. I'm not dealing with the 0 here any further. So bring down the 1, multiply, add, multiply, and add. Doing this, I've just proven that 1 is in fact a 0. Fantastic. Now, continue, bring down the 1, multiply, and add. Wonderful. Notice that our zeros are in fact -4, 1, and 1. It's kind of hard to read, so let's use, say, green. And it's a little bit better. So our zeros are -4, 1, and 1, whereas this 1 down here, that is the leading coefficient. Always remember, this single value down here will just be the leading coefficient, which is in fact a 1 here. Wonderful. Now, looking at the end behavior, we kind of skipped over that, but let's go ahead and go back to it. The end behavior is the leading power function, and the leading power function here is y equals x cubed. Because it's cubic, it's either down to the left and up to the right, or up to the left and down to the right. This happens if the leading coefficient is positive. This happens if the leading coefficient is negative. The leading coefficient is a positive one, therefore the end behavior is down to the left and up to the right. Alrighty, good. Now that we have that, we can also go ahead and write down the zeros. Now, we're actually only going to fill in 2 of these rows because there are, in fact, only 2 different zeros. There's a 0 of -4 and there's a 0 of 1. Notice that the -4 was only used once over here, so it has a multiplicity of 1. This 1, however, was listed twice in the zeros, so therefore it has a multiplicity of 2. Fantastic. And the behavior of this function at each of the at each of the zeros, well, first of all, there's a multiplicity of 1, therefore it crosses at the -4. Multiplicity of 2 means that it bounces at the 1. By the way, just a FYI, we can actually factor this function as x plus 4 times x minus 1 squared. And the way that I know that, this -4 means a factor of x plus 4, and this 1 means a factor of x minus 1, and these are the exponents on them. Notice the leading coefficient of 1 means that there's a leading coefficient of 1 here. Just, an FYI. Fantastic. Now for the last bit, we want to figure out the y-intercept. To do so, just replace all the x values with 0. So for the y-intercept, we have y equals 0 cubed plus 2 times 0 squared plus 2 times, minus 7 times 0 plus 4. Notice that all of these are 0 and we're just left with that constant term of 4. So the y value is 4, so the y-intercept is the coordinate 0, 4. Awesome. Now that we have all of this information, we can go ahead and use it. I'm going to go ahead and plot the zeros first of -4 and positive 1. Fantastic. Now plotting the end behavior. Notice that we're going down to the left and up to the right. So to the left of the first 0, we are going down, and to the right of the last 0, we are going up. Awesome. At the -4, we cross in a linear fashion. So at this -4, we cross to the other side. We also have 0, 4 as a y-intercept. So we're going up through here, then we'll go back down through the 4, go down to x equal 1, and we're going to bounce here off of it, back up to the end behavior. So just kind of connect everything with a curve at this point. And there you go. This is a graph or a sketch of a graph that looks similar to what the function actually looks like. Now, it's not perfect by any stretch of the imagination, but it has the important information. It has the x-intercepts, the y-intercept, the end behavior, and the correct behavior at the zeros. That's what I care about. Alrighty. Well, I believe I'm going to go ahead and leave it here, and I will see you in the next video. Have fun.